Okay, so we got our player. Save scene, save project. I mean, there's no chance of hanging, but it's a good idea. Unity does its own thing. So it's waiting, and there we go. Let's follow our player down this treacherous road. And so no matter how fast the player moves, when it gets within that distance, it will, gosh, why does it do that? I should stay focused. Oh, we can stay focused. We can lock. Don't want to lock this guy. I want to lock the slab manager. So we can change some of the stuff. Focus the player. And here we have our minimum distance. So if the minimum distance is higher, it's going to have to spawn a lot more just in case, but it always waits for the half a second. So that should get very, very long over this wait time. So if the wait time was very small, it'll go ahead and spit them out. Let's say our minimum distance is 100. So it will prepare at that distance, that many for us there. So that's cool. So I think what's next is let's shorten that min distance back to 6. That should give us 2. I'm gonna wait it out. Yeah, I got here. Okay. So we're almost at the end, it seems. We have minimum distance of. So if I put my minimum distance to 3, that'll be 1 chunk. Anything smaller, we're risking falling off the edge. Right. So I think this algorithm right now will work. Let's fix that error if we can. I don't even know what kind of error that was or when it occurred. So maybe it occurred in here because this is like, what the hell? So we always wait, and how about we never wait? So we no longer have a wait time. We only have a distance. Okay. So in the distance is always the next one that spawns. And the next one that spawns will always be further away from me. Alright, that makes sense in my head. Hope you're following along. Okay, so next is to turn the slab manager into a slab manager pooler. Right? So again, multiple approaches. We can use the first approach that I can think of as to build the object pooler right into this class. Secondly, we can build an object pooler that's just generic. Okay, so I prefer the first option, as the lesson will probably build a generic object pooler soon. I think yeah. What should we do? What is best to do this time? Best to do this time is build a generic object pooler. Okay, let's build a generic object pooler. use the utility class. So we got a generic pool. You don't need that. So our generic pool class is a static pool that you can add any object type to. Hang on, let me make sense of this. The object type will be the key, namely the prefab. So on awake, you add your prefab to the generic pool, and that's how you access the generic pool. Generic pool spawn this prefab. Thank you very much. So let's build that. So we'll need a dictionary. I'm gonna go with private right now. Or internal. I'm not sure if no modifier, access modifier means private or internal. So I think they're different depending on if it's a field or a class or either or. But right now we'll keep it here, hidden away, and it'll be a dictionary of GameObjects that has a list has a list of pool of generic. So this would be like a pool manager. So we're gonna need two of these classes. Let's just save this crappy stuff out. So we need a pool manager, and we need a generic pool. So the generic pool would be a list of the game objects that's going to be used. So that's right, and it's not a static class, and it takes a generic type where T is a component. I think we can use component. So where T is a component, and that would mean any script attached. And we send in a T here for our list. And we need an access modifier. So let's get one of those. Objects. I don't think those are names used for namespace anywhere. Definitely needs to be private. And that might be it. So pool.add, that might be a function we need. Yeah, we're not gonna expose that like that. We're gonna use an indexer to do that. So I like the indexer. So we return a T, and that's the index. Need to expand those a bit. Take that down. So getting and setting any pool item will happen through here. So let's validate our index here. So if index is less than 0, right, or it's greater than our objects count -1. Then we throw an exception. So we throw index out of range exception. It's probably in the system namespace. Index. Pool component so actually it might be better for the user if we return that, but our message would be a string format that'll give them an indication of the range that they're exceeding. So string format, we'll just use our same message. So first of all, we need the range, right? And at 0, we can just put that in to the count of the objects -1 and the current index. That way they have a full report. So can not be out of range. So let's give them an indication of the range. 0 and 1. And we can close that off. I put it kind of backwards, or we could just move it. Doesn't really matter. I could left it there and use 3 here, the third index, which is number 2, of course. So that's the index. So that'll give us a. So index or pool component cannot be out of range 0 to blah blah blah. That's a full indication of what's going on. So if we're all good there, let's return that item. So we're good. And setting the item, let's do that privately, and that way we can make sure at least everything comes through here. You know, if we want to fire off an on creation or something like that, then we can do it. So something like on access, something accesses the pool, you can throw a little event that fires in here. Anyway, this might not be necessary, but I don't think it's necessary. So let's add an item to the pool. We can only get. If it was added, adding an item to the pool, so the generic pool is not expandable. Okay, so we'll just instantiate the pool. Is that how you spell that word there? We do that. Have a there we go. Let's see how bad my spelling was there. Man, that's spot on. My spelling is getting a little bit better. Still scary. So we instantiate how many? Int one-time instantiation. So now we just add them to the pool, right? Instantiate. Let's get a bool out of here. No, we don't want to do that either. See, that's what I'm saying. If we want to inherit and make an expandable pool, then we will. But this pool does not expand. It doesn't even know if it should be declaring a new or not. And so we declare that, instantiate, and in instantiation, we do a lazy instantiation of this guy. Alright, so if it equals null, equals new, then we could just set it to that size. And that should make this pool very, very efficient. So we're going to need an index for accessing the next item and a local space index in the class. The type of pool I like to implement is a running pool. I call it that because it never looks for another object. It just uses the next one in line. So you'd have to maintain however many objects you think you'll need. And that way I guess that's its maximum efficiency I can put into the pool as far as it playing. So memory, of course, if it's gonna always have an object ready, it's gonna have to put it in memory. So I just noticed that this should be a 0. So it's got to put it in memory. So that's the trade-off. So define when and where and how. So if we're null, we instantiate and we create. Visual Studios, you start typing and you tap twice and you get your little snippets. And that's a pretty cool feature. So yeah, and this might need to be an amount. Don't know if it actually creates the list at that size when this is called. So now we define our prefab, right? So the generic pool instantiates a bunch of t's. At this point, it doesn't really know what t is, and nor does it care, but it still needs a reference to a t, some t, any t. So we're going to save a reference to the t also, and we're going to call it prefab. So this is its prefab, and that's going to be null, which makes sense to also initialize this guy to null. So now we're null all over. And also, let's check for null here. We'll throw a new. Well, Unity will do that for us, right? Yeah. We'll let Unity take care of that part. There's not a reference. Unity throws a null reference, and let us be the ones in charge of that. So we need a t, instantiated t of a prefab. When we instantiate, we save our prefab. Alright. So if prefab does not equal null, then we're going to return, but actually we're going to use a Unity error here. Now, let's keep it simple. Get the prefab. We'll initialize our pool. actually T obj equals GameObject instantiate, and we already know what we're instantiating is the prefab, or T, I'm sorry, T of the prefab, and positioning, rotation, all that stuff, who cares? It's not the pool's job. So now the pool knows what it's instantiating, and it instantiates them all. But what the pool will do, however, it will deactivate the component. We know it's a component. We know there's a game object attached. And thinking if it should parent itself. Now let's just deactivate, and since this is a component, that way we know we're instantiating some type of component. Okay, so now we instantiate our component prefab, so it won't be able to be a game object. I think that might be a mistake. Yeah, it has to have a script attached that we're going to be accessing. Alright, so this would be a generic pool of components. We'll just leave it at that. So now we instantiate our pool, which took a very long time. And now our pool manager is going to have a dictionary of the prefab that we're going to be spawning and our generic pool. Yeah. So generic pool, that's fine. I see the problem. The generic pool just needs to be a game object. And that's for good reason. It makes sense anyway. It's a static and it's called pools. Okay, so has to be a game object. Okay, it's use game object and can't use it as a base class. So our generic pool is not a generic pool of classes, is a game object. So we get our prefab game object, we declare our list of game objects, we accept our game object prefab, we declare, instantiate, and we redefine. And now that we've redefined, we know it's a game object, we can set it active, and we can store them ready for use. So we have our prefab. Let's make this serializable. Okay, so you're that. Where is this set from? It may not need to be serializable. Okay, let's get into the pool manager. Okay, so now we have our pools. Pool manager is going to instantiate a pool, and the pool takes the prefab and the amount. So when this happens, we're going to, this is a static read only. So that equals a new dictionary, of course, of don't know how much we're going to start off with. So we have our pools. Pools.add the prefab of a new list of generic pools at that amount. No, just the pool. We want one pool. Something's not, yeah, okay, so I got it. So we add yeah, the list is on the other side, man. Then something seems a bit fishy here. And we're like way too many lists. And we'd be flooded with items. Okay, so we add a new generic pool. And adding a new generic pool, just leave it at that. We can send in the prefab and the amount, actually. And that will be our instantiate. Right? So if we do that, I don't need this wacky stuff. And just call our instantiate function on our prefab and our amount. Alright, that looks about right. So we add a new pool. Done deal. So now on retrieval, we're also going to use an indexer here, but we're going to be returning a generic pool, right? And the index is going to be a GameObject. And let's just call that prefab, huh? So again, we follow the same pattern. Let's see what we want to make private and or public. So if prefab is null, then we throw a new argument cannot be null exception, probably also in the system namespace. Argument null exception. Okay, we'll do that. So prefab for pool reference cannot be null. And there's there's nothing else I can do. I can't give a name or anything if it's null. And if not, then we get our pools and loop that prefab and we return it all. Alright, once returned, be okay on that. Yeah, I keep forgetting to start up this Twitch alert stuff. Okay, that's counter. Did I miss anything? I'm so sorry. Okay, that looks like what I saw last night. So I don't want to close it. I want to, yeah. Okay, back to it. So now we have our pool manager. Our pool manager 10, huh? Ooh, maybe we'll finish this later on. I take a break and shop and prepare for the stream this evening. Anyway, let's finish the accessor. Okay, so now we have our generic pool. We're getting the pool. So when we do that, what happens? So we're getting a dictionary of generic pool, and generic pool has nothing in it. And the setter, let's just leave that out for now. So the pool itself needs to cycle through the objects. Right? So we need an integer. Current index, set that to 0. I think might need to be like a negative 1. No, 0, 0. 0 is fine. I prefer negative 1, but anyway. And the getter, that's a specific one. I can just get that index if I know what it is. But if I do not, I need a public GameObject we can just get an object. First thing get an object is going to do, it's going to say our current index equals our current index plus 1, which we mod that entire thing by our pool count. Alright, so that way we know we're not exceeding any values here. Then we add and we return. So plussing 1 to this would take it to 1, and we would end up skipping our first item. Setting this to -1 here, let's do it when we instantiate our pool. We instantiate or when we create? When we create the pool. Instantiation is just that, it's just instantiation. Speaking of which, the prefab should not be in here either. So we should be setting our prefab here, and then we should instantiate the amount that we need from our prefab. We set our current index, we set our prefab, then we instantiate that amount. Sweet deal. So now we need to get a handle. Might want to add that in there too. obj, add obj. So now we can either return TURN this current index, or we could return objects index. And that's how we get an object, and it always just returns the next one. So we're responsible for maintaining the size. The size is not sufficient, it's going to be reusing objects that's already in existence and needed. Okay, I like to also so we get object, hang on, get object and get object active. Alright, we'll call get object, So var, let's just use GameObject for now. Obj equals the object that I'm getting. Need that. And after I retrieve the object, I return it, not before setting it active. Okay? What would be a better choice? Is there a better choice? Is this a better choice? Get object. Activate. And we always call that. And then we have 2, which doesn't activate the object. And we set it to activate. Or we go always set it to false. Or our desired behavior, of course. So if I return an object, I personally, I never want it activated from a pool. I prefer it to give it to me deactivated, because I may need to position and do all sorts of things to it before I show it. So I don't know what works for you. So we can restrict this to a private. This is ambiguous. Maybe provide some ambiguity. So let's just get it all out of here. Okay, our getting object is our getting object. So where's our obj? And then I decide to set it active or not. Alright, so we'll just use a default parameter, default value for our parameter there. You don't say anything, it's not going to be active. You do, it will. So now we can get an object from our pool. So now if the pool manager wants to get an object, it says pool manager, and it gets the pool. Then from the pool you can get an object. Okay? So now the pool manager can be called right here from our trusty old slab manager. On start, call pool manager. We don't have any static methods over there. Okay. I wonder, is that so we're going to create a pool from that. Let's see. We can't do it twice. I'm not going to provide any safeguards for that right now. Let's just say pool manager. And let's create a pool from, we should have access to that prefab already, because there's our slab prefab. And how many do we want to generate? Let's save that amount for the pool amount. Let's just define that here. So we have our prefab, we have our integer of the amount that we want to spawn in the pool, and we'll default that to around 10. Okay, so now we've created our pool. Let's generic pool equals pool manager dot, oh, hang on. need an instance, so no static indexers allowed. So we have no static indexer, and so let's redefine what we do. Snip this little thingy on here, and that's our new generic pool getter. So we create the pool, and then we get the pool. And now that we can get the pool in a static way, dot get pool, and let's say what pool we want to get. So now we have access to our pool, and we can do what pools do, right? So they should be all created for us, and then we just, every time we just need to get an object, and in this case we're gonna activate it and see what happens. TRUE. So getting the object gives me that object, so that's cool too. We no longer need to instantiate it here. I've done that already, and we do all the same things here. When do we deactivate the object? Because we're quickly going to run out of objects. Oh, we're not. It's going to use the 10 and it's just going to continue building. So we're good. No more running out. No more regeneration. And no need for destruction. Okay, that was a lot of coding without checking anything. Let's see where we went good and where we went bad. Our console, we're missing a reference. That was an error from before. Or I should have paused, right? Anyway, we have no changes here. We're good. We have our slab that we sit on to start. And our player, no changes. We spawn 10 of those guys. Let's go. So object spawn manager has been destroyed and you're still trying to access it. That's interesting. Let's see where that happens. So we have just inspector, window, so we don't have any errors in our code. How about if I save the scene, save the project, and I'm going to close it all down and get it up and running again. It's the slab manager. We have our slab manager. We have our generic pool, none of which are mono behaviors. And we have our player controller. Have our utilities class. Let's start up Unity again and see if our problem no longer exists. Boulder run, and we're using this one here. And we need only press play. So no errors. And let's keep an eye on our pool while we see they're disappearing from here. Not because they're being remade, but because that they're being requested again. Yeah, man. So that's it. So we have 10 objects being reused. Oh,